Hello, this is the video for time, speed and distance advanced. So in this video we will discuss the past CAT repeated questions, and I will suggest that you will watch or go through this video after completing the concepts video and the basics video first. So let's start with the CAT repeated questions. And in this question is a CAT 2018 slot 1 question, and it is a bit tricky because information that is given to us is much more as compared to other questions that we have solved till now. But the main thing that I want you to do in this kind of questions is to make a line diagram and put every information that is given to us in the question in that diagram. And if you represent that information carefully, you can solve this type of questions also very easily. Now let us go through the questions once. Train T leaves station X for station Y at 3 p.m. Train S, traveling at 3/4 of the speed of train T, leaves Y for X at 4 p.m. Okay, now let us make a diagram. Let this be point X and this be my point Y. We know that train T is leaving from X, train S is leaving from Y. Train S starts at 4 p.m. and we are given that train T starts at 3 p.m. This much is the information, and if I assume that train T travels at t meters per second, we are given that train S travels at 3/4 of the speed at which train X travels. So speed of train S is going to be 0.75 times of T, or 3/4 of speed of the train T. Now we are given that two trains pass each other at station Z. Let us assume that this is station Z which we have provided. It is also given that the distance between X and Z is 3/5 of the distance between X and Y. And if I assume that this distance is something, if I assume that this entire distance is A, so this will be 3/5 of A and this will be 2/5 of A. This is the information that we have provided, because distance of X and Z is 3/5 of the net distance of X and Y. Now we are asked that how many hours does train T take for its journey from X and Y. Now this is the entire information that we have provided, and we have plotted it on a diagram so it is easy to understand and we do not have to go and read the question once again. Now let us try to solve this question. Now we can understand one thing, that train T is going to travel 1 hour more because it is starting 1 hour earlier than train S. Okay, now let us assume that both the trains meet X hours after 3 p.m. I'm assuming that two trains meet X hours after 3 p.m. Hence, in this time duration, train T would have traveled for X hours, and my train S, as it starts 1 hour after train T, will have traveled X minus 1 hours. And the speed, this is the time, and the speed at which train T is traveling is assumed by us as T, and this is 0.75 T. And we also know that if I equate the distances between both of them, it will be 3/2, because this is 3/5 of the distance and this is the 2/5 of the distance. So let us try to form a ratio equation which is something like this. Distance of train T upon distance of train S is equal to 3/5 of A that we have plotted on the diagram, and this is 2/5 of A, that is nothing but equal to 3/2. And if I substitute the basic formula for distance, that is speed multiplied by time, so this is equal to X multiplied by T upon X minus 1 multiplied by 0.75 T. So this is our equation number 1. Now if I try to solve this equation, I'm left with 2xt is equal to 2.25 xt multiplied by, minus 2.25 t, or t gets cancelled out over here, and we are left with 0.25x is equal to 2.25, or x is equal to 9 hours. Now what we x equals to 9 hours, but in 9 hours train T covers 3/5 of the distance, 3/5 of A in 9 hours. But we are asked that how much time does train T take for its journey from X to Y. Hence we need to multiply 9 by 5 by 3 and we are left with T equals to 15 hours. So most of the students do the entire process correctly and they mark x equals to 9 hours as their answer and lose out the marks even after solving this question correctly. So do not do the basic errors or silly mistakes while solving the questions. After getting your answer, I will suggest that if you have some sort of time with you, you better cross check that what is demanded from you in the question itself. Now, I hope this concept is clear to you. Moving to the next question. Question number 2, even this question is from CAT 2018. We are given that distance from A to B is 60 kilometers. Partha and Narayan start from A at the same time and move towards B. Partha takes 4 hours more than Narayan to reach B. Moreover, Partha reaches the midpoint of A and B 2 hours before Narayan reaches B. Okay, the speed of the Partha in km per hour is, okay, we are required to calculate the speed of Partha. Now this is a linear movement. Both of them have started from the same point, from A towards B. So no need of diagram as such. Everything is very clear. Now if I assume that time taken by Partha is equal to x hours. Now we are provided that Partha takes 4 hours more, hence time taken by Narayan will be equal to x minus 4 hours. Is it clear till now? Now moving on. We do know that the distance between A to B is 60 kilometers. Now if I have to calculate speed for Partha and Narayan, it will be nothing but 60 by x, and this will be 60 upon x minus 4. Now we are given another condition that till Partha reaches the midpoint of B, A and B, 2 hours before Narayan reaches B. So we'll rewrite this equation in terms of time. Half of the distance between A and B is 30 kilometers and time is equal to distance upon speed. This is the formula that we are using over here, and speed which we have calculated is 30 upon 60 by x. This is the equation for Partha. He takes, this is the distance, plus 2 because it takes 2 hours less than Narayan to reach B. Okay, so I can equate it with the time required by Narayan to reach the distance, cover the entire distance, that is 60 upon x plus x minus 4. I hope this equation is clear to you. We were given that time required by Narayan is 2 hours less, hence we added 2 hours in this and equated both of them, and after solving I will get my x equals to 12, or Partha requires 12 hours to complete 60 kilometers and we have to find speed of Partha, which is nothing but 60 upon x, as I will substitute the value of x which we have got over here, or 60 by 12, which is equal to 5 kilometers per hour. This question was fairly straightforward. Moving to the next question. Question number 3. In this question we are provided that on a long stretch of east-west road, A and B are 2 points such that B is 350 kilometers west of A. One car starts from A, another from B at the same time. If they move towards each other, then they meet after 1 hour. Okay. If they both move towards east, then they meet in 7 hours. The difference between their speed in kilometers per hour is. Now in this question again we will need to draw the diagram, and there is a concept involved in this question which is logical. So that is the catch in this question, nothing else. Let us draw the question diagram. We are given that A and B are points 350 kilometers apart and B is to the west of A. So B will be here and the distance between them is 350 kilometers. This is point A. Let's say that the car that is starting from A is having speed of x kilometers per hour, and car starting from B will be of y kilometers per hour speed. Now we are given that initially both of them move towards each other and they require 1 hour to meet, and afterwards both of them start moving in the east direction and they both meet in 7 hours. Now one thing to note over here, which is very important, while both of them are moving against each other, they are definitely going to meet at some point between A and B. But when both of them are moving in the east direction, they can only meet if B is going to overtake A. So I can conclude from this information that y is going to be greater than x. This is the catch in this question that I was talking about earlier. Now moving to the equations part. Let me form the equations for you. Now one thing is that we have studied the concept of relative speed. In this case, when both of them are moving towards each other, their speed is going to be x plus y. And while they are moving away from each other or in the same direction, the relative speed is going to be the difference. And this difference is going to be y minus x. As we have stated earlier that y is greater than x, hence it is going to be y minus x and not x minus y. Now we are given that when both of them are moving in this opposite direction or towards each other, they require only 1 hour. So time is nothing but distance upon speed. Distance is 350 kilometers upon their speed relatively is x plus y, and this is equal to 1 hour. Hence this is my first equation, 350 is equal to x plus y. Another equation will be, again the distance, relative distance between A and B is going to be 350 kilometers. So this is the one thing that I was talking about initially, where relative speeds concept is very easier. It makes our questions very easy. So this is when 350 minus upon y minus x is equal to 7 hours. Now if I was going to use absolute speeds, I will have to assume some point over here where both of them will be meeting, and in that scenario both of them would have traveled some different distances. But as we are using relative speed concept, B has to travel only 350 kilometers with respect to A, and hence this equation is being made. And this is equal to 350 is equal to 7 multiplied by y minus x. This is my equation number 2. If I solve both of these equations simultaneously, I will be getting my y minus x is equal to 350 by 7, that is equal to 50 kilometers per hour. Now one thing to note over here is that we have to find only the difference between the speeds. So as I told you that you need to read the questions carefully, there was no need to solve the equations. We just have to solve y minus x in this scenario. Okay, so the answer in this scenario is 50 kilometers per hour. I hope you got the concept that y and the speed of car starting from B is greater than the speed of car that is starting from A. In this question, we are given that point A and B are 150 kilometers apart. Car 1 and 2 travel from A to B, but car 2 starts from A when car 1 is already 20 kilometers away from A. So we are given that A and B are 2 points which are 150 kilometers away. It is given that car 2 starts when car 1 has already covered 20 kilometers. We are also given that each car travels at the speed of 100 kilometers per hour for first 50 kilometers, that is rest after starting, 50 kilometers per hour for the next 50 kilometers, and 25 kilometers per hour for last 50 kilometers. Okay, so the distance in kilometer when car 2 and B, when car 1 reaches B, as car 1 has a head start of 20 kilometers, we are asked that when car 1 reaches B, what will be the distance between car 2 and B? This is asked to us. Now, we are given that for the first 50 kilometers, speed is 100 kilometers per hour. For the next 50 kilometers, we are given that the speed is 50 kilometers per hour. For the last 50 kilometers, speed is again 25 kilometers per hour. Now, time required to travel 50 kilometers at 100 kilometers per hour is 0.5 hours. Time required to travel 50 kilometers at 50 kilometers per hour is 1 hour. And time required to travel 50 kilometers at a rate of 25 kilometers per hour is equal to 2 hours. Hence, net time required to complete this entire lap is going to be addition of all of this, or 3.5 hours. I hope it is clear till now. Now we are given that car 1 has a head start of 20 kilometers. Now the car 1 time taken by the car 1 to reach B so the time required by car 1 to reach B after car 2 starts is equal to, please note this equation, time required by car 1 to reach B after car 2 starts is going to be equal to total time minus the time required by car 1 to travel initial 20 kilometers. Because this equation is quite logical. The net time required by car 1 to reach point B after car 2 starts is equal to the total time required by car 1 minus the time required to travel initial 20 kilometers. So this time is equal to, as we found out that initially the net time required is 3.5 hours. Now to cover initial 20 kilometers, initially we are given that it is traveling at 100 kilometers per hour. So the time in this scenario will be 20 by 100, or we are left with 3.3 hours. Hence, after car 2 starts, car 1 is going to travel for 3.3 hours, and similarly in this time frame, car 2 is also going to travel for 3.3 hours. So initially, now I am writing the equation for car number 2. So in initial 0.5 hour, it is going to travel 50 kilometers because its speed is going to be 100 kilometers per hour. In the next 1 hour, it is going to travel for another 50 kilometers. Now this total comes out to be 1.5 hours. Now it is having a time of 3.3 minus 1.5 hours left with it. So it is going to travel 1.8 hour at a speed of 25 kilometers per hour. So the distance that it will travel is 25 multiplied by 1.8, or this is equal to 47.5 kilometers. Hence the net distance traveled by car 2 is 50 plus 50 plus 47.5, or that is equal to 147.5, or the distance that we require is 150 minus 147.5, that is 2.5 kilometers. I hope this is clear. A man leaves his home and walks at a speed of 12 kilometers per hour, reaching the railway station 10 minutes after train had departed. If instead he had walked at a speed of 15 kilometers per hour, he would have reached station 10 minutes before the train's departure. Okay, so the distance between his home and railway station is. Now, in both the scenarios, distance that he is going to travel is constant. Initially, he is going to travel at 12 kilometers per hour, and he is going to get or require 10 minutes more. And after he is going to travel at 15 kilometers per hour and he is going to require 10 minutes less. But in both the scenarios, he is going to travel the same distance. So I can equate the distances that he has traveled. So distance is equal to time multiplied by speed. So initially he is taking, let's say that he takes t minutes if he would have walked for at x pace, at x kilometers per hour, he is requiring t hours to complete this distance. But we are given that if he walks at 12 kilometers per hour, he is requiring 10 minutes more. So this will be 10 minutes in terms of hour is 1/6, and this is equal to, if he travels at 15 kilometers per hour, he is going to require 10 minutes less, that is t minus 1/6. So this is the equation that we have to equate, and if I solve this equation, this will be 4 times, this will be 5 times. 4t plus 4/6 is equal to 5t minus 5/6, or I am left with t is equal to 9/6 or t is equal to 3/2 hours. Now I have to calculate the distance in kilometers. If I substitute the value of t in any of this equation, I will be getting my answer. So 12 multiplied by t, that is 3/2 in this scenario, plus 1/6, this is equal to 20 kilometers. This is a pretty straightforward question. We are given that Arun drove from his home to his hostel at 60 miles per hour. While returning home, halfway along the way, he drove at a speed of 25 miles per hour, and then he took a bypass road which increased his distance by 5 miles, but allowed him to drive at 50 miles per hour along this bypass road. If his return journey took 30 minutes more than his onward journey, then what is the distance traveled by him? Okay, so let the distance from his home to hostel be x kilometers. Okay, now the time required for his onward journey will be x by 60, because initially we are given that his speed was 60 miles per hour. So this is the time required for the onward journey. Okay, now we will calculate time required for the return journey. Time required in the return journey, it will be equal to, till the halfway he has traveled at a speed of 25 miles per hour, plus during the return journey, after driving halfway, he took a bypass which increased his distance by 5 miles. So he traveled x/2 plus 5 kilometers, but in this scenario his speed increased to 50 miles per hour. So this is the time required during the return journey, and we are given that his return journey took 30 minutes more. So if I subtract equation number 2 from equation number 1, it will be equal to half hour or 30 minutes. So subtracting equation 1 from equation 2 will be equal to 0.5 hours. So let us solve this equation. Pretty basic one. X by 60 plus 0.5, I am just rewriting the equation, is equal to x by 50 plus x by 2 plus 5 by 50. On solving, I am going to get my x equals to 30. Therefore, the distance that he traveled hence the net distance that he will have traveled is going to be equal to 2x plus 5, because during his onward journey he would have traveled 30 kilometers, during his return journey he would have traveled 30 kilometers plus 5 kilometers of that bypass road. So this is equal to 60 plus 5, or this is equal to 65 kilometers would be traveled by Arun during his entire journey. This is a CAT 2017 question. Very straightforward question. A motorbike leaves point A at 1 p.m. and moves towards point B at a uniform speed. car leaves point B at 2 p.m. and moves towards point A at uniform speed, which is double that of the motorbike. Okay. They meet at 3:40 at a point which is 168 kilometers away from A. What is the distance between A and B? Okay, let this be A point, let this be point B. We know that motorbike starts at 1 p.m. Car starts at 2 p.m. Both of them meet at a point which is 168 kilometers away from A. This distance is 168 kilometers. They meet at 3:40 p.m. Hence the time for which the motorbike would have traveled will be from 1 p.m. to 3:40 p.m. That is equal to 2 hours 40 minutes. Similarly, car would have traveled for 1 hour 40 minutes because we are given that it is starting its travel from 2 p.m. Now we can write this equation for motorcycle, that is motorcycle covers 168 kilometers in 2 hours 40 minutes or 2 hours 2 by 3 hours or 8 by 3 hours to be precise. Hence the speed of motorbike is going to be distance upon time, that is equal to 21 multiplied by 3 or 63 kilometers per hour. Hence the speed of car, that is twice of the motorbike, will be 126 kilometers per hour. Now I have to calculate the distance between A and B. I already know from point A till the point of meeting, let that be x, it is equal to 168 kilometers. This distance is going to be distance covered by car. It is going to be speed of the car multiplied by time taken by the car. Now we know that the speed of the car is 126 kilometers. Time taken by car is 1 hour 40 minutes, or it is equal to 100 minutes converted into hour. This is equal to 210 kilometers. So I know that this distance is 210 kilometers. Initial distance is 168 kilometers. Hence the distance AB in this scenario will be 168 plus 210. This is equal to 378 kilometers.